let's talk about the squared Euclidean distance, which is a common dissimilarity measure we used in the clustering algorithm like the k-means. So it quantifies how different of 2 points, x and y, are in d-dimensional space. So its squared Euclidean distance is we used to calculate by just summing the squares of the differences between the corresponding components of the points. So this measure is more important because it forms the basis of the cost function that clustering algorithms which attempt to minimize to form coherent clusters where the data points within the same cluster are more similar because they are closer in the terms of Euclidean distance, right? That is why they are more similar to each other than compared with those in the other clusters. So we just visualize how this dissimilarity measure increases as 2 points in two-dimensional space move away from each other. So like the graph show that the squared Euclidean distance between a fixed point and the various points along a line. So this illustrates how the distance increases quadratically as the separation between the points increases. So this graph illustrates how the squared Euclidean distance from a fixed point here at 0, 0 and changes to other points y moves along with the x-axis from -10 to +10. So this distance is calculated by using a formula which is the delta of xy equals the sum from a equal to 1 to d equal to 1 of the quantity xa minus ya and then all squared, where the d is the dimensionality, and in this 1D case, it involves just the x-coordinates since the y-coordinate is 0 for both points. As we can see, the distance forms a parabola, which indicates that the squared Euclidean distance increases quadratically as the separation between the 2 points increases. So the distance is minimized when the 2 points are the same, which means they are at the x-coordinate 0 in this case, and it increases symmetrically as the y moves away from the x in either direction. So this graph exemplifies why the squared Euclidean distance is a potent tool for clustering. It emphasizes the differences as points move further apart, but pushing the algorithm to form clusters where the points are tightly grouped. So just by minimizing the intra-cluster distance while maximizing the distance to the points that are in other clusters. Delta of xy equals to the sum of the vector x minus y squared, which is equals the sum from a equal to 1 to d of the quantity of xa minus ya and then all squared. So this formula is used for calculating the squared Euclidean distance between the 2 points x and y in d-dimensional space. And then we just sum in the squares of the differences between their corresponding components. We expand this formula and essentially we just write out the sum explicitly for the dimension d.